Okay, so good evening. Okay. Today we'll be starting vectors. Can the students who have joined online confirm whether the sound is okay? All good, no? Okay, today we'll be starting a new lesson and we are going to commence applied maths. And as per discussed in the beginning of the class, we know combined maths is word combine comes because of the combination of two components. Because combined maths is not a subject in maths. So that is something that we have made because we have combined two components in maths. One is pure maths and the other component is applied maths. So that's why we have the subject called like combined maths. But when you go to, let's say that you go to a university to do engineering or especially to do physical, where you will be working with these math subjects. And in when you go to the university, you won't hear the word called combined maths. Especially when you are doing this physical science section, physical science faculties, we'll be having separately pure maths modules. So we in university, we don't call it as a subject, we call it as a module. So why do we call it as a module? Because the subject that we are studying is maths. So in general, the subject is maths. Inside maths, we have separated maths into separate branches and areas, and we are going to study those areas. So for example, if I take a lesson inside maths, let's say polynomials. So polynomials is not a subject. That is a unit inside maths. So when you go to a university, we work with modules. We call it as a module. So when you go to the university, we don't hear this word combine. You will be having separate pure maths modules and separate applied maths modules. Okay, so combine comes because in our A-level syllabus, we know what happened in 2000. There was a major educational reform. So in that educational reform, like previously, the A-level subjects, there were four subjects. If you ask your parents how many subjects they did for their A-levels, they have done four subjects. So if you are doing maths, they had chemistry, physics, pure maths, and applied maths. But then in 2000, they have reduced it up to three subjects. So when they have reduced it up to three subjects, this pure maths and applied maths they have taken around 60% from each component of each subject, and they have made this subject combined maths. It's not, we can't say exactly it is 50%, 60%, but based on the subject matter that it was in the previous syllabus and the current syllabus, we can say it's around 60% of the syllabuses. The two syllabus has been taken and they have made up this combined maths. Similarly, they did for biology. Previously, there were two subjects, zoology and botany. Zoology, the study of animals, and botany, the study of plants. So they have combined those two subjects and they have put the name biology. But in that case, they have more bias to zoology because when you're doing biology, you are expecting to become a doctor. So that means that the more amount is to zoology, where we study about animals. So it's not a 60-60 or 50% ratio, but in A-level combined maths, both of these areas are having an equal weight. We are having two separate papers, which is termed as combined maths 1 and combined maths 2. So even in the syllabus, they haven't mentioned pure maths. We go with the name combined maths 1 and combined maths 2. So we are getting two papers, equal papers, 10 first part questions, 7 essay questions where you have to select 5 questions, 10 first part questions, and 7 essay questions where you have to select 5 questions. So in the pure maths paper, you get 1000 marks. For the applied maths paper, you get 1000 marks. So out of 1000, the combined maths paper, you get marks out of 2000. And when you divide it by 20, you get the final mark for combined maths out of 100. So this is how your syllabus goes. So today is the first day of applied maths and we'll be starting vectors. So vectors is the foundation of applied maths. Vectors, it's the foundation of applied maths because vectors will be connected to many lessons in your applied math syllabus. After the next applied lesson that we are going to do is planar forces. You need the vector knowledge for planar forces. And when we are doing lessons like relative acceleration, relative velocity, we even require the knowledge of vectors. So this is like the foundation of applied maths, and the foundation of PO maths is trigonometry, because trigonometry will be repeatedly found in the syllabus inside many units. So today we'll be starting vectors, and in between the class, since there are a considerable amount of newcomers at the middle of the class, I'll talk to them separately what to do, and especially the students who have joined online as new students. So you can continue from here. You can start from here, even though let's say that this is the most probably a new student who come today, is that he has gone to another combined maths class, and because might not like he's not that class is not his class, so maybe he has made that change. So most probably a student who come to this class as a newcomer now in these days, they have previously gone to another combined maths class, but there might be students who just decided to do maths, and there might be a student who has come here from a bio class. Their mother wanted them to become a doctor, so they went to the bio class for like 6 7 months, and they realized this is not my thing. I don't want to work with animals and plants. Maths is my thing, and they might make the decision and come to do maths. So even though you are a student who has gone to a maths class previously, or this is your first day in a maths class, that is totally okay. We can start from the beginning because you have come in a good day. We are starting vectors, so we can start from here. Clear? Okay, so then write the main topic, vectors. Write the main topic, vectors. Okay, so when we are talking about vectors, we need to first learn about the definition of a vector. So in general, if I talk about quantities and I ask, I'll describe this in this way. I'm telling you that my mass, normally we are telling the mass, but we mention it as the weight. You know that is wrong. When you fill a form, it is given as the weight. But as science students, we know no, that is not the weight. We are referring to the mass. So I'm telling you, okay, my mass is 67 kilograms. So that's all. So that is my actual weight. So I'm telling it's 67. So that's all. Then you won't be asking any question. Okay, and even I can't explain about this furthermore because it's just a numerical value. My mass is, oh, I'm not telling my weight. Even though my mass is doesn't sound familiar, we know that is the correct thing. What sounds familiar is my weight is. So we do those things. No? When we tell the correct one, it doesn't sound familiar. For example, when you get caught to the police when you're driving, we say, okay, he's asking license එක දෙන්න කියලා. But we know that is wrong. It's not license. This is English medium class. No, it's not license. It's license. But when I say, okay, I got my driving license, that doesn't sound correct. That doesn't sound familiar because we have been familiar with the wrong term. So this is even something like this. When I say my mass is 67, it doesn't sound familiar. But if I say my weight is that I know because those two rhymes, weight and height. But as a science student, we know that is not a weight. This is the mass. Then I'll be giving another thing. I'm telling you that I'm applying a force. I'm applying a force of 20 newtons on this object. I'm applying a force of 20 newtons on this object. And I'll be asking a question, to which direction this object will be moving. I'm asking you a question. Okay, I have applied a force of 20 newtons on this object. To which direction will this object move? Then you are asking me a counter question. So to which direction did you apply the force? Because I just mentioned that the force is 20 newtons, but I didn't give a direction. So when I ask that question, you will be asking me a counter question. Sir, to which direction did you apply the force? Okay, then I have to be more specific. Okay, the force has been applied to this direction and it is 20 newtons. And then you will be telling me, okay, so that means the object starts moving. If we ignore the friction, if we neglect the friction, the object will be start moving to this direction. So now it gives you a clear understanding. When I gave this quantity, the mass, It is 67 kilograms, that's all. But when I'm referring to a force, given that it is 20 newtons is not sufficient to have an understanding about the force. So then I told you the force is applied to this direction. That means there are two types of quantities. There are two types of quantities. One type is you can explain about the quantity, or the quantity can be given using the magnitude. Using the magnitude. The magnitude is 67 kilograms. So here the magnitude is 20 newtons. So there are two quantities. One quantity, the magnitude is sufficient. We only have the magnitude. But now it's clear there are some quantities where the magnitude, only given the magnitude is not sufficient. So some quantities should be given in terms of the magnitude plus the direction. Magnitude plus the direction. So based on this, we say there are two types of quantities. If the quantity only consists of a magnitude, we name it as a scalar quantity. And if it consists of a magnitude and a direction, both, we name it as a vector quantity. So we name it as a vector quantity. So that is the first thing that we have to learn in vectors. Clear? Okay, write in this way. Write in this way. There are two types of quantities. There are two types of quantities. There are two types of quantities. Okay, under that, write the first one using a black pen. Number one, scale quantities. Using a black pen, scale quantities. And under that, put a dash and write in this way. Under that, put a dash and write it this way. Quantities which only consist of a magnitude. Quantities which only consist of a magnitude. And then write the examples. We have the mass, the distance, and density. The mass, distance, and density. Okay, then write number two using a black pen. Number two, vector quantities. Number two, vector quantities. Okay, under that, write in this way. Quantities which consist of a magnitude and direction. Quantities which consist of a magnitude and direction. And write the examples. Force, displacement, velocity. Force, displacement, and velocity. Okay. Now tell me, in physics, did you learn that vector and a vector quantity is the same, or is it two different things? A vector, you have done vectors in physics, no? Hands up who have done vectors in physics. In physics. Luckily, it was in physics. If it was in chemistry, you would have told that I'm doing ICT. Okay, so in physics, okay, tell me, did you learn vector and a vector quantity as two different things or one the same meaning? Hands up who learned it as two different things, vector and a vector quantity. Okay, hands up who have learned it in the as the same thing. So others like probably can't even remember like did they learn such a thing. Okay, so a vector and a vector quantity are two different things. A vector, like if I say, like later will be after this one, I'll be explaining about the notation of a vector. So if I draw an arrow in this way and I say that is just 2, so the direction of the vector is to this direction and the magnitude is 2. So this is a vector. But if I say, okay, this direction it's 2 newtons, if a vector is given with a unit, that is a vector quantity. So that is a vector quantity. So we refer to a quantity, vector quantity, when the vector has been given in terms of a unit. So what are even in scalars, that's the same thing. So scalar we have two, scalar and a scalar quantity. So 2, 3 are just scalar quantity, just scalars. If I say 2 kilograms, 3, the speed ms minus 1, these are scalar quantities. Okay, so when we refer to a quantity, that means we are referring to a particular measurement. It consists of a unit. So a vector and vector quantity are two different things. Is it clear? We hands up. Is it clear? And I know that probably you have learned that for physics, but that's okay. You have been learning like been 2, 3 years before, no? So probably you can't remember. We write in this way. Write in this way. Write in this way. If a vector, if a vector, if a vector is only given, a vector is only given using a magnitude and direction, is only given using a magnitude and direction, magnitude and a direction, it is known as, it is known as, write in a black pen, it is known as a vector. It is known as a vector. Okay, so after that, after that line, write in this way. So what is the example that I'm going to give? If we have just given in this way, a 2, that's all. So here is the magnitude and the direction, 4. So these are vectors. These are vectors and it might be A, B. This is a vector. So later we'll be learning what are these. For now, just write 2, 4 and A, B. No unit means it's a vector. No unit means it's a vector. Okay, then next line, write in this way. If the vector consists of a unit, if the vector consists of a unit, consists of a unit, it is known as, it is known as, write in a black pen, vector quantity. It is known as vector quantity. Okay, then write this example, 2 newtons, 4 ms minus 1. 2 newtons to this direction, 4 ms minus 1. So we have the unit. So when we have the unit, Those are quantities. Then let's write the same thing to scalars. Write in this way, if the scalar, if the scalar is only given, the scalar is only given in terms of a magnitude, in terms of a magnitude, it is known as a, it is known as a, write in a black pen, scalar. It is known as a scalar. Okay. Then write the examples, just write 2, 3, just two numbers, 2 and 3. Okay, then next line. If the scalar, if the scalar consists of a unit, if the scalar consists of a unit, it is known as a, write in a black pen, scalar quantity. It is known as a scalar quantity, and write the two examples, 2 kilograms and 3 meters. Okay, then write the topic, main topic, vector notation. Silence, silence, silence. Write the main topic, vector notation. Silence. Okay, so there are two ways that we can denote a vector. So that's why we say it as a vector notation. So two ways. One way is the geometrical notation, or the geometric notation, and the other one is notation, the algebraic notation. So there are two main notations that we are going to use to denote a vector. Okay. So first one, when it is a geometric notation, geometrical notation. Geometric or figure? Geometric, no? Yeah, geometric notation. So how do we, like, mama kiwat tamay tetaning hadanne. Okay. So how do we denote this in a geometrical way? A vector is denoted by a line segment consisting of one arrowhead with a single arrowhead. So we denote a vector, silence, we denote a vector using a line segment consisting of a single arrowhead. So I told you a vector consists of two things, two components, a direction and the magnitude. So this single arrowhead denotes the direction of the vector, and the length of the line segment that denotes the magnitude of the vector. Later we'll be bringing a term called modulus of the vector. So we know the modulus and the magnitude are the same meanings. So the single arrowhead denotes the direction and the length of the line segment denotes the magnitude of the vector. Okay, so here we can say the vector, it may be a force, velocity, displacement, it is towards this direction. Okay, so write in this way, there are two main ways. There are two main ways a vector can be denoted. There are two main ways a vector can be denoted. A vector can be denoted. Under that, write the first one using a black pen. Geometric notation. Geometric notation. Geometric notation. Okay, then under that, write it this way. A vector is denoted by a vector is denoted by a line segment with a single arrowhead. A vector is denoted by a line segment with a single arrowhead. Same line. The length of the line segment, the length of the line segment denotes the magnitude of the vector, denotes the magnitude of the vector, denotes the magnitude of the vector, and the arrowhead, denotes the direction of the vector. And the arrowhead denotes the direction of the vector. Okay, then draw this one and show that this is the direction. And the length of the line segment denotes the magnitude. Okay, so this is the direction, this is the magnitude. And then put number two. Number two, algebraic notation. Number two, algebraic notation. Okay, then under that, write it this way. A vector can be denoted. A vector can be denoted a vector can be denoted in one of the following ways. In one of the following ways. That's a vector can be denoted in one of the following ways. So when it is algebraic notation, there are three main ways. One way is if you are referring to the vector AB, we use a arrow over this AB. So that is one notation. So there is another notation if I'm referring to a simple letter. You can underline this one, which denotes that it's a vector. And there are instances where even you can denote a vector in this way. That is okay. But normally, when we are using two vectors to denote a vector, two letters to denote a vector, we use a arrow. And when it is a single letter, we normally underline that. But inside a paper or let's say a question, if you see something like this, that is totally okay. And even this can be in this way. Because I told you, these are not rules. There is no any rule. When we are having two letters, you need to put an arrow. And when there is one letter, you need to underline that. Those are not rules. Those are just practices. So normally we denote in this way. And there is another way. You can denote a vector, especially when you are printing it. You can use a bold letter. What you get when you put Control B in this Microsoft Word. So this one is a notation even you can use. But you can't just write it. When you're printing a document, you can do that. For example, look at this page number 10 in the tute. Page number 10. And look at question number 31. Page number 10, question number 31. You can see these U, V, A, B letters have been printed in a bold way. That means those are vectors. Question number 31 in page number 10. Those are vectors. Okay. So we can use these methods either using arrow above the vector or underline the vector, or you can print it in a bold way. Okay, so I gave vector can be denoted in one of the following ways. Then write these three. I mentioned this is bold letters. Okay, then write a small topic. Small topic. Modulus within brackets magnitude. Modulus within brackets magnitude of a vector. Modulus or the magnitude of a vector. Okay, so that we discussed here. I told you the magnitude means the modulus means the magnitude of the vector. So when you denote a vector in the geometric way, the geometric notation, the length of this line segment gives you the modulus or the magnitude of a vector. So it is denoted in this way. Let's say here we have vector OA. OA is a vector, and this modulus of the vector is given by the same modulus mark. So we represent the magnitude or the modulus of a vector using this. So this is the modulus of vector OA. If you write this in this way, that means the modulus or the modulus or the magnitude of vector OA. Clear? So same meaning, small things are these are small theory points, but we need to have a crystal clear idea about this because I'm explaining this like assuming that you haven't learned physics. So that's how I do this. Most of the lessons that you are learning in mechanics will be later learned or explained in applied maths in a deep way. For example, in physics, we have a small area called circular motion. Under mechanics, we will be doing that. So in physics, let's say it's the circular motion will be around a 2-3 mark part out of 100. But in applied maths, the circular motion is a big lesson where you have 75 marks out of 100, out of 1000. So those most of the parts except these hydraulic parts, every part, friction, force, then circular motion, most of every part in mechanics will be later explained deeply in applied maths. But when I'm explaining that, I don't assume that you have done this in physics. I know you have done this in physics and I know these are small things, but I'll be completely ignoring that one and teaching from the beginning. Okay, so same thing, the modulus. So it's denoted in this way. It's the length of this line segment. So if you consider the length of this line segment, it is the modulus of OA. Okay, then write in this way, the modulus of a vector, modulus of the vector, which is also known as the magnitude, which is also known as the magnitude. The modulus of a vector, which is also known as the magnitude, is the numerical value, is the numerical value of the vector, is the numerical value of the vector. It is denoted by, it is denoted by using a red pen, just write 2 lines. It is denoted by, phone should be silence. Using a red pen, consider 2 lines. Okay. Then draw this one, vector OA, and OA is the modulus or the magnitude of vector OA. Draw this line, name this, and even write this. Okay, then write a subtopic, a small topic, negative vector. Write a subtopic, negative vector. Okay. So what is the negative vector? Now let's say we are having a vector A. And then there is another vector which is having a same magnitude, which is having the same magnitude as this vector. And it is even parallel. The two vectors are parallel. So the two vectors are parallel. But the direction of this vector is opposite to this one. So two vectors are equal in magnitude, but and those are parallel, but the direction of this vector is opposite to this one. This vector is known as the negative vector of this one. So what is a negative vector? The negative vector is the vector that is equal in magnitude, parallel to the same vector, but there is one condition, it should be opposite in direction. So we can say equal in magnitude, parallel and opposite in the direction, and this is the negative vector. So the negative vector of A is minus A. Okay, write in this way, write in this way, the vector with a equal magnitude, the vector with a equal magnitude, comma, parallel, comma, parallel, but opposite to the direction, but opposite to the direction, opposite to the direction of a given vector, of a given vector is known as the write in a black pen, negative vector is known as the negative vector. And then draw these two. Here we got the vector parallel to this one, equal in magnitude, but opposite in direction is the negative vector. The same meaning minus vector. Okay, so here this is the negative vector. And then again put a small topic. Equality of two vectors. The phone should be silent, I can't repeat. And I won't be repeating, I'll be taking the phone. Try a small topic. Equality of two vectors. Equality of two vectors. Equality of two vectors. Okay. Okay, so if you can remember the lesson polynomials, tell me what are the two conditions that should be satisfied if two polynomials are equal. Polynomials, we did a lesson. The degrees should be equal, and when the degrees are equal, the corresponding coefficient should be equal. So there are two components of a polynomial to be equal. The degrees should be equal, which means they should be in the same class. And when the degrees are equal, we say that the corresponding coefficient should be equal. So a vector consists of two components. The vector consists of a magnitude and the direction. So if we are referring that the two vectors are equal, both the components should be equal. No? Both the components should be equal, which means we can say if the magnitude and the direction of two vectors are equal, if the magnitude and the direction of two vectors are equal, we can say that the two vectors are equal. Clear? So if we have two vectors, let's say we are having two vectors. Here we have A and we have B. If the if the magnitude of these two vectors are equal, modulus A is equal to modulus B, these are magnitude. If this one is equal to this and they are having the same direction, which means those two are parallel, the magnitude is equal, the direction is equal, then we can say that vector A is equal to vector B. Then we can say that vector A is equal to vector B. So the magnitude and the direction both should be equal. So what is this? Modulus A equals modulus B. That means magnitudes are equal. There was the same direction and parallel, which means the directions are equal. Which means the directions are equal. Clear? Okay, write in this way, small stuff. Write in this way. Since a vector consists of a magnitude and direction, comma, if two vectors are equal, both the magnitude and direction should be equal. Both the magnitude and direction should be equal. Both the magnitude and direction should be equal. Okay, then consider these two. We have A and B. So then we have the magnitudes are equal, the directions are equal. So then the two vectors are equal. So if you write vector A equals vector B, so here the vectors are equal. Okay. Okay, then write the topic. Write in a black pen the topic. So these are normal topics, no equality of two vectors and minus negative vectors. So write in a black pen parallel vectors. An important point in vectors, parallel vectors. Parallel vectors. Okay. Okay, so here, like, let's say we are having this vector A. And now let's say that we are having another vector which is parallel to this vector A. So when it is parallel, we know the two directions are equal. So this vector A consists of two components. There is a direction and there is a magnitude. But when we are referring to the direction of these two vectors, the directions are equal. So if I take this as vector A, okay, I'm naming this as vector A. So this is 50% correct because this A consists of a magnitude and a direction. So when we are talking about a parallel vector, even the direction of this vector is same as this vector. So if I write this as A, 50% is correct. Why is it 50%? Because the direction is correct. The direction is correct. But what is wrong? The magnitude, don't sleep, hey, wake up. Killing in there. Doesn't know. Okay, back straight. කාලයක් ඇති කොහොමද නැවෙනව ඕක. මගේ පොඩ නැවෙනවා. Okay. Okay, so here this is 50% correct. Why is it 50% correct? Because the direction is correct. But I know the magnitude is wrong. Okay, now let's say that this vector is having a magnitude is greater than this one, 2 times greater than this one. Then the magnitude of this vector is 2 times greater than this one. Then it is clear, if this is A, you know that you can denote this one as 2A. Because A is for the direction and 2 is because the magnitude of this vector is 2 times greater than this one. So when it is 3 times greater, then we can name it as 3A. If it is only half of the size of this, then I can name this vector as half A. And then it is clear that you get the idea. Any vector parallel to vector A, any vector parallel to vector A can be denoted as Ka. Any vector parallel to A can be denoted as Ka, and K is a constant that depends on the magnitude of the vector. If it is 2 times greater, it's 2A. If it is 3 times greater, it's 3A. If it is only half of this vector, it is half A. Clear? So any vector parallel to vector A can be denoted as Ka. K depends on the சொல்லுங்க. K depends on what? Magnitude of the vector. Killing in PVR depends on the magnitude of the vector. Clear? Okay. So write in this way. Write in this way. A vector parallel to any vector parallel to any vector parallel to vector A, underline A, any vector parallel to vector A can be expressed as write in a red pen Ka. So only underline A. Yeah? In Ka, only underline A. Here K is a constant. Here K is a constant. So you can use another word. K is a constant. Like let's forget about a constant. So something that we learned today at the beginning of the lesson. K is a vector. K is a scalar or scalar quantity. Hands up if you are telling it's a scale. Hands up if you are telling it's a scalar quantity. No, it's not a quantity because it's just 2, 3. So it's a scalar. Okay. So here K is a constant. You can write within brackets scalar. Okay. That depends on the magnitude of the vector. Here K is a constant that depends on the magnitude of the vector. Magnitude of the vector. Okay, then write down these examples. So A is the starting vector. So we have 2A, 3A. In general, we can consider K, A. Okay. Okay, now there is an important property that we need to discuss in parallel vectors. Okay, now look at this. Silencer. Now look at this. If we say that we have this vector A and any vector can be written in terms of A. No? So you can express any parallel vector which is parallel to A in terms of A. So if you use this here, look at this. Now, let's say that AB is one vector and we are having another vector CD. And let's say that the magnitude of CD is twice than the magnitude of AB, which means vector CD is equal to 2 times vector AB. Or you can write in this way, vector AB is equal to half of CD. Or you can write that vector AB is equal to half of CD, which means when two vectors are parallel to each other, listen this properly, when two vectors are parallel to each other, one vector can be expressed using the other vector in terms of the other one. When two vectors are parallel to each other, one vector can be expressed in terms of the other vector. Can be expressed in terms of the other vector. So we say we have this property or the property. We have in two words, dependent and independent. So I have explained this under which lesson? Dependent and independent. Not history, independent day anyway. In maths, in functions. If you can remember, we discussed about dependent variables and independent variables. What was the dependent variable? Y or X. කනාරි කියන්නකෝ නිකන් හරියනවා නම් යනකම ස්විප් එකක් අරගෙන යන්න. The dependent variable is y and the independent variable is x. Okay, silent. So now it's clear we use this word dependent and independent. If okay, silence. So you are dependent, you are totally dependent to your parents. You are totally ඕමි ගාන මොකද? Plain ඕමි. හතර දෙනා නෑ. Okay. Okay. Then this way, don't sit in a diagonal way, ready to talk with the person behind to you. Just sit properly. රුවිතට ඉන්න එපා. Diagonal way එකට ඉන්න එපා. Okay. So we are having these two words, dependent and independent. So you are dependent to your parents. There's no one here who does a job and earns himself. You might be earning in different ways, but you are totally dependent to your parents. No? 100% you are dependent. So why you are dependent? According to your father's salary, that decides your lifestyle. For example, the phone that you are using is a reflection of your family's financial background. But there are some deviations where even though the family is having a hard financial situation in the family, your phone must be like 300,000, 400,000 phone. There are special deviations in that way. So there are like special cases, but if not, the things that you use, the way that you dress, the quality and the prices of all the dresses that you wear reflects your not your family's financial background. So that means you are dependent to your parents, but your parents are not dependent to you. The parents are not dependent on you. They are independent from you. So you are like parasites. We all were parasites. I used to be a parasite, but not anymore. You are parasites. You are dependent, 100% dependent to your parents. So here, now look at this. Now when AB changes, listen. When AB changes, what can you say about CD? When AB changes, CD even, speaking, tell me. When AB changes, CD even changes. When CD changes, AB even changes, which means if there is a change in AB, that change will even affect CD. So what can you say about AB and CD? Are they dependent or are they independent? They are dependent. They are dependent because it's clear when this changes, even this changes. So here we say that when two vectors are parallel to each other, we can express the vectors in terms of the other one. So CD can be written in terms of the other vector. ABE can be written in terms of the other vector, which means they are dependent. So we can say that parallel vectors are dependent to each other. So why do we call them as dependent vectors? Because one vector can be expressed in terms of the other vector. One vector can be expressed in terms of the other vector. Okay. Write in this way. Hence it is clear. Hence it is clear when two vectors are parallel, one vector can be expressed. One vector can be expressed in terms of the other vector. One vector can be expressed in terms of the other vector. Okay, same line. when one vector, when one vector can be expressed in terms of the other vector, the other vector, the two vectors are, the two vectors are, write in a black pen, dependent. The two vectors are dependent. And then write in a red pen, write in a red pen, parallel vectors are, then write in a red pen, parallel vectors are dependent. Parallel vectors are dependent. Okay, and then write down this. We have AB and CD. So given that AB is parallel to CB, then when you write this in terms of this, when you write this in terms of this, sorry, in terms of the other vector, you can say that the two vectors are dependent. Okay, so when two vectors are parallel, we can say that they are dependent. When two vectors are parallel, we can say that the two vectors are even dependent. Okay. So there's always this converse of a theorem. No? If you can remember, we did this factor theorem. So what is factor theorem? So I'm not asking questions from O levels. I'm asking questions from A levels. What we have done. You can now tell me what is a factor theorem? What is factor theorem? What is factor theorem? Gunda, you all are giving a confidence for the new students, because normally when a new student come to the class, they are asking me the questions. Can we cover? Like, how can we cover the previous lessons? අලුතෙන් එක්කෙනෙක් අහම අහන්නේ මුලින්ම කලින් පාඩම් කොහොමද cover කරගන්නේ කියලා. Now when a new student come to here, when I ask a question, he get a good confidence. හිටපුන්ටත් බෑ යන මටත් හිටි අවුලක් වෙන්නේ නැහැ කියලා. කරගන්න පුළුවන් කියලා. Tell me, சொல்லுங்க. What is the factor theorem? If x minus a is a factor of fx, then fa is equal to 0. What is factor theorem? If x minus a is a factor of fx, then fa is equal to 0. So what is the converse of that? Means the opposite one, converse of that. If fa is equal to 0, then we can say that x minus a is a factor. So similarly, we can have a converse of this one. So when two vectors are parallel, we can say that the two vectors are dependent. Now let's say when we are solving a vector problem and we get a expression like this, I'm getting that AB is equal to 3 times CD. So I'm getting an expression. So after simplification process, I'm getting that AB is equal to 3 times CD. Okay, now tell me, what can you say about these two vectors? AB is equal to 3 times CD. What can you say about these two vectors? You can't say it's parallel. First thing that you can say that the two vectors are dependent. Our two vectors are dependent. And then I know dependent vectors are parallel to each other. Parallel vectors are dependent. Similarly, dependent vectors are parallel. So if you can write one vector in terms of the other vector, then you can directly you can't say it's parallel. What you can say, AB and CD are dependent vectors. So how can you say that those are dependent? You need to write one vector in terms of the other vector. A, B, and C, D are dependent vectors. So we know parallel vectors are dependent. The converse, dependent vectors are parallel. Therefore, you can write that A, B, and C, D are parallel vectors. A, B, and C, D are parallel vectors. So this will be used most probably even today when we have to prove that three lines are collinear. So we will be using vectors to prove that not three lines, 3 points are collinear. For that purpose, we need to know this. Okay, so write in this way. Similarly, 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 write in a red pen, this one. So similarly, then write in a red pen. Dependent vectors are parallel to each other. Similarly, dependent vectors are parallel to each other. Are parallel to each other. Okay, then write in this way. Look at the board. You can say if AB is equal to 3 times CD, if AB is equal to 3 times CD, AB is equal to 3 times CD, AB and CD are dependent. AB and CD are dependent. So when one vector is expressed in terms of the other, we say it's dependent. So therefore, AB and CD are parallel vectors. AB and CD are parallel. Okay, I'll give you 1 minute. If there's anything to complete in the note, you can complete and drink some water. Okay. Okay, then write the main topic. Silence. Okay, write the main topic. Addition of vectors. Silence. Write the main topic. Addition of vectors. Addition of vectors. Okay. So addition of vectors. So this is something that we need to discuss even using some laws. The reason when we are referring to addition of two scalars, we don't put a topic. No, might probably in grade 1, 2. I can't remember whether you had a topic. When you were in grade 1, 2, did we put topics? Matrugadana? Can't remember. No? Okay, so there might be a topic about these adding numbers, but we don't separately put a topic addition of scalars. Because 2 plus 3, it's 5, that's all. 2 plus 3, we have two magnitudes. When two magnitudes are added, you can simply write it 2 plus 3 is equal to 5. For example, if we have a object with a mass of 3 kilograms and with a mass of 2 kilograms, and if I ask you to add these two scalar quantities, you can say it's simply 2 kilograms added to 3 kilograms gives you 5 kilograms. But now let's say that we have two vectors. Two vectors. Here we have a 20 Newton force. And here, silence, we have a 10 Newton force. So now it's clear that the two magnitudes of the vectors are 20 and 10, but there is a direction. And now if I ask you to add these two vectors, you can't simply say, okay, when I add this vector 20 newtons and 10 newtons, I get the vector 30 newtons. You can't simply add the magnitude here. Okay, let's say that you get the magnitude. You get the magnitude when you add these two, you say it's 30. Let's say it's 30. But then you are getting a question, okay, it is 30 newtons to which direction? It's 30 newtons to which direction? Because when it is a vector, there should be a direction. So even though you think, okay, when we are adding two vectors, the two magnitudes are added each other, how can we take the direction of this 30 newtons? You can't just say, okay, it is 30 newtons to this direction. So that's why, since a vector consists of a direction and a magnitude, we need to discuss about the addition of vectors in a separate manner. You can't just simply add the magnitudes. But there is a special case where you can simply add the magnitudes. What is the special case? Let's say we are having an object, and here, okay, we are having a 20 Newton force, and here it's a 10 Newton force. Okay, now if I ask you to add these two, then it is clear both the two vectors are having the same direction. So when the direction is the same one, like assume that I'm here, I have been pulled by a 20 Newton force and a 10 Newton force. So what is the collectively, what is the force that I'll be feeling? It's 30 newtons. So it's clear. When I ask you to add these two vectors, then you say, okay, sir, it's 30 newtons the same direction. Which means when the two vectors are parallel or when they are in the same direction, when they are parallel or when they are in the same direction, then you can say the magnitudes will be added each other and the addition vector, which later will be termed as resultant vector, for now it's the addition vector, is having the same direction as the two directions of the two vectors. So that is a special case. So then we have to learn about the addition of vectors under two topics. One is when the two vectors are parallel or having the same direction. The second one, when the two vectors are not having same direction. Clear? So here they are having the same direction. Here they are not having the same direction. And later I'll be given a topic for the difference between the vectors. So under that one, we'll be explaining if we have 20 to this direction and 10 to this direction, how can we do that? I'll be explaining that later. For now, only two types: vectors with the same direction and vectors with different directions. Are we clear? Okay, hands up if what I just mentioned, is this clear? Okay, that's all enough for me. We write in this way, write in this way, vector addition should be discussed, under the following two instances. Vector addition should be discussed under the following two instances. Okay, under that, using a black pen, write number one. Using a black pen, number one. When the direction of the vectors are equal. When the direction of the vectors are equal. When the direction of the vectors are equal. Okay. So then it is clear. Look at this. We are having vector A in this direction plus vector B in this direction. So when you add them, how do we... Okay, silence. Huh? So once you have joined online, I saw that in the previous one, silence. One student, maybe probably a new student, have asked why is this late? That happens because there was a power cut. If not, like normally, I just don't go out of the classroom while we are having the class. I only go out when there's an interval. So we had a power cut, and there are generators here. You know that there are generators, but there is issue with switching on the generator. That's why we couldn't continue the class. But now it's okay. We are having the normal electricity. Okay, can do. Okay, and let's say in case like that happens in the future, and we won't be able to continue the online class, you don't have to mind about that, because I'll be wait. So like let's say a similar case happens in the future, So in that case, I'll be doing a separate session for the online students to cover the area that we are going to do if that happens in the future. So you don't have to mind about that. If that happens, I'll notice in the group and we'll, okay, I'll do a separate online session. But today there's no issue. We can continue from here. So I gave, we were talking about vector addition, and I told that vector addition should be discussed under the following two instances. Number one is when the direction of the vectors are equal. Okay, so here, silence. So it's clear how we do this. When we have two vectors, we need to add two vectors with the same direction. First, when you draw one vector A, and from the point where we stop this vector, draw the second vector, vector B. So that is what we have to do. So vector addition is simply that. First, draw the first vector, vector A, and then after this, at the end point of this vector, draw the next vector, vector B. So then this vector gives you the addition vector A plus B. Gives you the addition vector. We call this as the addition vector. Later I'll term it as the resultant vector as A plus B. So how do we get the addition vector? First draw one vector and then draw the second vector from the point where we have n the first vector, and then this vector is A plus B. Okay, then write in this way. The sound is clear, right? Then write in this way. Write in this way. When the direction of the vectors are equal, when the direction of the vectors are equal, when the direction of the vectors are equal, the magnitudes of the vector, magnitude of the vectors the magnitude of the vectors will be directly added, will be directly added, will be directly added, and the direction of the addition vector and the direction of the addition vector will be having the same direction, will be having the same direction of the vectors, will be having the same direction of the vectors. Okay. Then for this one, we have A and B equal in direction. So the addition vector is to the same direction, and you can see the magnitudes get added each other, A plus B. The magnitudes get added each other. Okay, so this is not only valid for two vectors. Let's say we are having three vectors to the same direction, A, B, and C. And when you consider the addition of all these vectors, what you have to do, first draw one vector from the endpoint, start the other vector B. From that endpoint, start the third vector C. So this vector gives you the addition vector A plus B plus C. So not only for two vectors, even though we have 3, 4, 5, any number of vectors with the same direction, it's the same. Okay, so after this one, even write down this one, we have three vectors. So in the lesson vectors, I won't be using the word resultant vector because it doesn't give a sense. But when we are talking about forces, and the resultant force gives you an idea. So here I'm not going to, inside this lesson, I'm not going to use the word resultant vector because it doesn't sense properly. But in general, the addition vector is the resultant vector. Okay. Then write number 2. Write number 2. When the direction of the vectors, when the direction of the vectors are not equal, when the direction of vectors are not equal. Okay, so now we are having vectors where the direction is not equal. So now let's say we have A and B. It's clear that we are having two vectors with different directions. To add these two, we will be discussing mainly two laws in vector addition. So in vector addition for two vectors, we have two laws in general. We have to learn about three laws. One is vector triangle law, vector parallelogram law, and the vector polygon law. So there are three rules or laws that we need to learn under addition of vectors. First one is vector triangle law in terms of a triangle, then vector parallelogram in terms of a parallelogram, and the vector polygon law. Okay, so then, so let's discuss these separately. Write in this way. Write in this way. To get the addition of vectors, to get the addition of vectors with different directions, with different directions, we have to consider the following three laws. The following three laws. Okay, then write 1, 2, and 3. The first one, vector triangle law. First one is vector triangle law. The second one, vector parallelogram law. Vector parallelogram law. Third one, vector polygon law. Vector polygon law. Okay, then under number 2. So we are in number 2, no, vector addition of vector addition when the vectors are having different directions. Then either subtopic, vector triangle law. Write the subtopic, vector triangle law. Vector triangle law. Okay. Okay. So this is how we do this. Now listen. So let's say we are having two vectors A and B. So I told you the same thing. So what you have to do, first draw vector A, and then from the point that you stop vector A, draw vector B. Draw vector B. And now when you consider the vector connecting the starting point and the end point, connecting the starting point and the end point, you get the addition vector of these two, which is A plus B. So you get the addition vector of these two, which is A plus B. So this is how we do this. So how did we do this? First, consider one vector or draw one vector. From the point where we stop this vector, draw the second one. And then the vector connecting the first one and the connecting the starting point and the end point is the addition vector. But there is a topic vector triangle law. So since there is a topic vector triangle law, so this is what is happening here. The But what does the vector triangle law state? The vector triangle law states when two sides of a triangle denotes two vectors, when two sides of a triangle denotes two vectors, the third side denotes the addition vector of the two vectors. So that is of the triangle law is given. Clear? When two sides of a triangle denotes two vectors, so two vectors are denoted by two sides of a triangle. The third side denotes the addition vector of those two vectors. But what we are doing here, first draw one vector, then from the endpoint, draw the second vector, then the vector connecting the starting point and the endpoint, we get this addition vector. Is it clear? Okay, so that is the law, but what happens here is in this. For example, you can remember what is Newton's second law. What was Newton's second law? Newton had three laws. What is the second law? You had that for O-level science, no? So what is the second one? Huh? What was the second one? The external unbalanced force is directly proportional to the mass and the acceleration. But when we are using the second law, what we simply use it F equals ma. Is it clear? So we have a Newton's second law. Listen. Hey, mo tama Thailand din ni. Okay. So Thailand ne kiye? You went to Thailand? දැන් එන්න ලංකාවට තාම ඒ වගේ. So here, listen, wait. So what is the science? Okay, so what is the second law of Newton? That the external unbalanced force is directly proportional to the mass and the acceleration. But when we are using that law, what we use is simply F equals ma. We don't consider that F is proportional to ma, and then F is equal to kma. According to the definition of a Newton, K becomes 1. No, do we consider that? No. When we are applying Newton's second law in a question, simply we put F equals ma. So same thing that we are having a vector triangle law. What is the vector triangle law? When two vectors are denoted by two sides of a triangle, the third side denotes the addition vector. But when we are using this, how can we do it? Draw one vector. From the endpoint, draw the second vector. The vector connecting the starting point and the endpoint gives you the addition vector. That's all. That's all we have to do. Forget about a triangle. Forget about a polygon. Whatever we do, simply this is the same thing. Is it clear? Okay, then vector triangle law inside quoted commas 66, 99, put 66 and write in this way. Quoted commas. Okay, write in this way. When two vectors are denoted by two sides of a triangle, when two vectors are denoted by two sides of a triangle, the third side denotes the addition vector. Third side denotes the addition vector of the two vectors. Denotes the addition vector of the two vectors. Okay, then draw this one and let's take another example. We have vector, so let's take a separate one. We have vector A here. We have vector B here. So what we have to do, first draw one vector A and then draw the other vector B. The vector connecting the starting point and the end point denotes the addition vector between the two vectors. So A plus B is the addition vector. Okay. Okay, so this is vector. Okay, I'll give time. So right now both these are vector triangle law. Okay, then write the next one, vector parallelogram law. Next one is vector parallelogram law. If you don't know to write parallelogram, shape එකේ බලන්න board එක. Vector parallelogram law. Okay. So what does the vector parallelogram law states? Listen. Now let's say we are having, okay, silence. Again, two vectors with two different directions. Silence, huh? And now when you denote these two vectors by the adjacent side of a parallelogram, by the adjacent sides of a parallelogram. So adjacent sides means the sides that are connected. So if this is A, the side connected with this one is B. If you denote the two vectors by the adjacent sides of the parallelogram, okay, then here is the parallelogram, here is the parallelogram. And then what does the vector parallelogram law says? It says that the diagonal that goes through these two vectors. We are having two diagonals. So this is one diagonal and this is the other diagonal. So here we are referring to the diagonal that is going through these two vectors. It denotes the addition vector. So this is the vector parallelogram law. What happens here? When the two vectors are denoted by the adjacent sides of a parallelogram, the diagonal that goes through these two vectors represent or denotes the addition vector. So this is A plus B. And the thing, even though there are three laws for vector addition, we have vector triangle, vector parallelogram, and vector polygon. All three will be the same vector triangle law. So inside all three, like first one is anyways vector triangle. Even in vector parallelogram, which is hidden inside is the vector triangle law. When we discuss vector polygon law, which is hidden inside that one is the vector triangle law. Again, හැමතැනම තියෙන vector triangle law එක. Why do I say so? Now look at this. If you consider this parallelogram, now this is A and this is B. Okay, now tell me what is a parallelogram? What is a parallelogram? A quadrilateral, okay. A quadrilateral where opposite sides are parallel and equal. It's wrong. It's not a parallelogram. The definition of a parallelogram is the opposite sides are parallel. That's all. A quadrilateral where the opposite sides are parallel is a definition of a parallelogram. What did you all say? Opposite sides are equal and parallel. That is a property of a parallelogram. So a property of a parallelogram and a definition of a parallelogram are two different things in maths. What is a square? A square is a rectangle with equal sides. A square is a rectangle with equal sides. But you can say the property is the two diagonals are equal. The two diagonals perpendicular, they are perpendicular to each other. And the angle is 90. So you can give different properties, but there is a definition. So what is the definition of a parallelogram? When the opposite sides of a quadrilateral are parallel, we name it as a parallelogram. And the opposite sides are equal, I admit. So that is not wrong. That is not a definition. That is a property of a parallelogram. So what is a rhombus? A parallelogram with equal sides. So what is a rhombus? A parallelogram with equal sides. Okay, so you know, now look at this. How do we connect these two vectors? Look at this. Modeban, look at this. So in a parallelogram, the opposite sides are equal and parallel. So if you consider about these two vectors, the two vectors are parallel and the two vectors are equal in magnitude. So tell me, when two vectors are parallel, to each other, which means the direction is same. The length is equal means the magnitude is same. When the direction and the magnitude of two vectors are equal, what can you say about the two vectors? The two vectors are equal, which means if this is B, even this one is, even this one is B. So forget about the parallelogram. We have A, we have B. Then forget about this side. If we have A and B, tell me what is this vector? A, B, this is A plus B. So even the parallelogram law of vectors, vector addition, is derived using triangle law. So what is inside this one? It's even the triangle law. But we are not going to mention that one. So this is the vector parallelogram law. Okay, write in this way, quoted commas. Write in this way. When two vectors are denoted by, when two vectors are denoted by, are denoted by the adjacent sides of a parallelogram, the adjacent sides of a parallelogram, adjacent sides of a parallelogram, the addition vector, the addition vector of the two vectors, the addition vector of the two vectors is denoted by, is denoted by the diagonal, the diagonal which goes through the vectors. The diagonal which goes through the vectors. The diagonal which goes through the vectors. Okay, then draw this one. We have A, B, and we got A, B. Okay. Okay, then write the last topic under vector addition, vector polygon law. Vector polygon law. Okay. So vector polygon law is the same thing, but we are using the vector polygon law when we are having three or more vectors, like when we have more than two vectors. So let's say we are having one vector A here. No, silence, focus. Kadanathan. We have B here and we have C here. So we will be repeating what I explained here. First row vector A, and then from the point you are stopping, row vector B. So repeat that from this point where you stop, row vector C. And the vector that is connecting the starting point and the end point gives you the addition vector A plus B plus C. So this is what happens in the polygon law, because even triangle is a polygon. Triangle is the simplest polygon. It's a simplest polygon with three sides. So same thing will be happening here. So this is what happens. The when okay, we'll be having a separate one. So let's say that we are having a four vectors. We have A and we have B here. We have C upwards and D in here. Okay, so I'll draw this in here. So here, how do we take it? We have A, and then we have B, and we have C going vertically upwards, and then we have D in this direction. So the vector which is connecting the starting point and the end point gives you the addition of all these vectors. So all these vectors A, B, C, and D. So this vector is A plus B plus C plus D vector. Okay, so how can we write it as a law, because this is the vector polygon law? So then I can give this in this way. If the sides of a polygon is denoted by vectors, the remaining side of the polygon denotes the addition of all these vectors. The addition of all these vectors. But there should be one condition. Make sure that the arrow goes in the same direction. Here you can see the arrow goes in the same way. Because if there is a direction change, the story changes. So here, how many vectors we got, there should be arrow in the same direction. Okay, so that's why. So how I'm going to give the vector polygon law? So this is what happens. Now it is clear this is what happens. But how am I going to give you the vector polygon law? When the sides of a polygon denotes vectors, or vectors are denoted by the sides of a polygon, the remaining side of the polygon denotes the addition vector of all the vectors. So that is what I'm going to write. But what happens is this. Okay, then write in quoted commas. Write in quoted commas. When vectors are denoted by the sides of a polygon, when vectors are denoted by the sides of a polygon, when vectors are denoted by the sides of a polygon, the remaining side of the polygon, the remaining side of the polygon denotes the addition vector, denotes the addition vector of all the vectors. The remaining side denotes the addition vector of all the vectors. Okay. Then write down these two examples. Here we have only 3 vectors, and here we have 4 vectors. So this is the addition vector. Okay, so even here it's clear that you got the vector triangle law. Because here, if you consider this vector, can now tell me what is this vector? We have A, B. What is this green colored vector? It's A plus B. No? So the green colored vector is A plus B. And then we have A plus B plus C gives you the addition vector. So what is even hidden inside the polygon law is the vector triangle law. Because it's clear, if we have this A and B and then we have C, what happens first here is A plus B gives you the A plus B vector according to vector triangle law. And then when you repeat vector triangle law, it's clear you get A plus B plus C gives you A plus B plus C. So we saw even in vector parallelogram law, we have vector triangle one. So similarly, even in the polygon one, even in the polygon law, we got the vector triangle law. Okay, so let's just write this down. Write in this way. Vector polygon law. Vector polygon law is derived. Vector polygon law is derived using the vector triangle law. Vector polygon law is derived using the vector triangle law. Vector triangle law. Okay, then take this. We have A, B, and C. So when you show that this is A plus B, it gives you idea. Triangle law 1, and then again triangle law has been applied. Okay. So this is how silence, son. So this is how we denote a vector addition in a silence algebraic way. Let's say we have A, B, and then vector B, C. So it's clear that we are considering the silence, son. Considering the addition of AB plus BC. And I know AB plus BC, the vectors, is equal to this vector, which means it's equal to vector AC. Because of this reason, we say AB plus BC, when you have these two are the same, B are same, we say that these two disappear to give you AC. So this is the algebraic notation of vector addition. When you have AB, here this stops by B, this starts from B. This one stops from B and this starts from B. So B cancel off to give you AC. Okay. Okay, then write it this way, put a right in a black pen, write note. In a black pen, write note. In front of that, use in a red pen, write algebraic notation of vector addition. Algebraic notation of vector addition. Algebraic notation of vector addition. Okay, write in this way. Write in this way. The algebraic notation of vector addition. Algebraic notation of vector addition can be derived using the triangle law in the following manner. In the following manner. Okay, then write this one. Draw the triangle and show that AB plus BC is equal to AC. AB BC is equal to this. Okay, AB plus BC is equal to AC. Okay, now look at the first question of the tute. Read the question. So online students, I have uploaded the tute and we have posted the tute. I think they posted it yesterday. So most probably the online students who have done the payments for the month of October, I think I asked them to send the tutes for the students who have paid for October, because you might take like 2-3 weeks to pay for November. So if you have done the payments for October, most probably by this week you will be getting the vector tute. And if you are a newcomer, I'll talk to them at the end of the class. Even for the online students, you can send them a message and get the tute. For now, I have uploaded the PDF in the group. Okay, so read the first question. First question. Sorry. Okay. The midpoints of sides BC, the midpoints of sides BC and DC of the parallelogram ABCD, IE and F. We have two midpoints. Given that AB is equal to half and AB is equal to A and AD is equal to B, find these vectors. Small thing. Look at the board now. So we have the parallelogram A, B, C, D. So when you are naming them, make sure you properly put the letters, because if they have given it as A, B, C, D, it should be the same sequence. Let's say there might be instances they have given A, B, D, C. Like they have given A, B, D, C. So then it should be A, B, even though the alphabetical order is A, B, C, D. If they have given it as A, B, D, C, then it should be A, B, D, and C. So it should be the same sequence. So here we have A, B, C, D, same as in the question. The two vectors A, B, and AD is equal to A and B. Is equal to A and B. The midpoints of BC and DC are E and F. So here we have E and F. So in these type of questions, the first thing that you need to do is you need the mark. You have to mark the possible data that you can mark easily. For example, you know if this vector is B, this is a parallelogram, then even this vector is, if this is B, this is even B. It's even B. And then if this is A, this vector is even A. So mark those data. And then this is the midpoint in this way. So first question is BC. So it's directly what you have written. You can just write BC is equal to B. That's all. You don't have to mention these two are parallel, equal inside. It's equal to B. And then we have CD. So before coming to this one, I have explained every theory point related to these type of questions, vectors and vector additions. So that is how normally we have to learn specially maths and physics. Because when you learn a theory, even in maths and physics, first you need to learn the theory in a rock solid way. And then only you have to think about how to apply the theory. Because when you are moving forward with both the syllabus, like physics and math syllabuses, what you normally do, what most of the students tend to do, first they learn the theory, but they are not that sure about the theory, and they are trying to understand the theory from a problem. They are trying to understand the theory while applying the theory. So that is not that is not the way that you have to learn maths and physics. First, you need to properly understand what is the theory. And then whatever the question type you get, you can simply apply the theory to that question. But I admit there are some instances, even though you learn the theory, you're not that sure about the theory, but when you start applying the theory, you get a proper understanding about the theory. There might be those instances where you understand perfectly the theory while applying it. එහෙම වෙන්න පුළුවන්. ගාන හදද්දි තමයි තේරෙන්නේ මේකෙන් මේ කියන්නේ මේක තමයි වෙන්නේ වැඩේ කියලා. That is okay. But make sure you have to learn the theories properly. ගණන් කොච්චර හදුවත් වැඩක් නැහැ theory එක දන්නේ නැත්තම්. මොකද ගාන වෙනස් කරපු ගමන් කරන්න බෑ. When they change the structure of the problem, you will find it hard to solve the question even though you have done 1,000 questions from that unit. So learn the theory very well. So I have explained the theory of each part that we require to solve this. So we have CD. Okay, now you can tell me if this is A, what can you say about vector CD? This is A, this is minus A. That is because that is the negative vector. No? That is the negative vector. Equal in magnitude, but opposite in direction. So it's minus A. And then we have AC. What is AC? Either using vector triangle law or using vector parallelogram law, you can say that AC is equal to A plus B. Vector triangle, this gives you A plus B. Vector parallelogram, these two are AB, so AC gives you. You can write it on AB plus BC, not necessary, but if you want, you can write it. Nikam A plus B දාන එක අවුල් වගේ නම් if you feel like just put in A plus B something like මදි වගේ, if you feel empty, you can write this AC AB plus BC, not necessary, but so what is question number 4? It's BD. I'll look at this BD. I'll look at this BD. How are we going to take BD? Start from B and go to D. Start from B and go to D. So you can either take BC plus CD or you can take BA plus AD. So that is how you add vectors. If you want to find the addition vector BD, start from B and go to D. මේ පාරද කියන්න එපා. Don't go like, don't take this one. Take another route. Start from B, BA plus AD. Now tell me, if AB is A, what is BA? Minus A. Plus, this is B. That means BD gives you, vector BD gives you minus A plus B. And then fifth one, BE. What is BE? Look at this. So where did we learn this? BE is half of BC. No? If BE is half of BC, tell me BE can be written as half BC. Where did we learn this? Under parallel vectors. Under parallel vectors. Look at this. BE and BC are parallel. Because they are parallel, BE can be written in terms of BC parallel vectors. And then it's half of BC, which means BE is equal to half B. This is equal to half B. Last one, CF. CF, same thing. Parallel vector CF can be written as half of CD. Same direction. Same direction. CF is half of CD. It should be the same direction. What is CD? CD is not A. CD is minus A. And then you have CF is minus half A. So this is how you take the vector addition. So how do we write these two? How did we write these two? BE equals to half BC and CF equals to half CD. That's because of parallel vectors. So every point have been discussed earlier. Okay. Hands up if this vector addition is clear, this one. Hands up if this is okay. Then do this one and the second one. So after this one, do question number 2. So second one is a regular hexagon. So what do we mean by regular hexagon? Is a hexagon where all the sides are equal. The next one is a regular hexagon. A, B, C, D, E, and F. Okay, so then we have AB is given as A, this is B, and this is C. So what did I mention when we were doing the previous question? I told you first looking at this, write all the vectors that you can easily write. So here, if this is A, you know this is A. If this is B, okay, then this is even B. If this is C, this is even C. Okay. Then first one is B, BC. Okay, it's can't be BC in your mind, like they're asking BC, no, so BC, they have given as a data, it can't be BC, but I'll just write it. Second one is CD. Okay, so instead of no, you can just find this. So, like you have written the first 6. No, then as question number 7, find AD. AD. And question number 8, find AE. So, as question number 7, find AD. And question number 8, find AE. Silence, silence. AE and AD. So this is a type in error where they have passed the given data. So third one is AC. A third one is AC. So how do you take AC? This way, I told you, start from A and go to C and add the vectors you get on the way. So you have A and B. Got another side? Stop talking. Okay. So AC is equal to AB plus BC. So then I get this one, AB is equal to A and BC is equal to B. So it's A plus B. And question number 4 is find BD. Okay, this is BD. You start from B and you go to D. So you can either take this path or this path, but take the easiest path. From B to D, it's B plus C, no? Stop talking. From B to D, take the easiest path. It's BC plus CD. Where BC is B plus this is C. And then question number 5. Find BE. Okay, so BE is this. So start. I told you start from B and go to E. So if you take this path, it's minus A plus C and plus B. Even you take this path, B plus C minus A. So you can write BE in this way. What is BE? It's B plus C minus A. I told you to add. I told you. Check, check, check. Yeah, damn. Okay. So here BE, I start from B and go to E. We have B, C, and minus A. But there is another way that you can write this vector. Look at this. So this is a regular hexagon. So we say this side is parallel to this one and even twice of the magnitude. So in this hexagon, it is having the property where this BE is parallel to CD and it is 2 times greater than CD. So if you consider that point, if this is C, tell me what is BE? If this is C, what is B? It's 2 times C. So even if someone has written that B, I was expecting this one because we are going with vector addition. So I'm expecting this. But if anyone has written this as 2C, that is even correct. Because this vector is parallel to this one and it is 2 times greater than this. Hands up anyone who wrote this as 2C. 1. Okay. So like you can even write that. Even that is correct because this is 2 times of this. For the next one, we need that knowledge. And then question number 6. CF, a CF you can, a CF is this, so CF. So I'll write CF, a CF is equal to minus B minus A plus C. Whatever the path you take, C minus A minus B. CF is equal to C minus A minus B. CF is C minus A minus B. Or same thing, you can write this as CF. It's clear this is A to this direction. Here the magnitude is 2 times, which means because of the direction change, it should be minus 2A. So even if you write that one, it's even correct. CF is twice of AB, so it's minus 2A. Because this is A, this is 2A, this is in the opposite one. Then I gave this additional one AD. Now it's clear. You can write AD. Same thing. So how to write AD? A plus B plus C. Yeah. AD is A plus B and plus C. Or even you can write it according to this one. It is twice of this. So AD can be written as 2 times of B because it's twice of this. This is equal to twice of this. And the last one, AE is equal to C plus B. B plus C. Okay. The hands up who have written these answers B, C, obvious. No, A plus B, B plus C, B plus C minus A, C minus A minus B, A plus B plus C, and A, B plus C. Hands up who have written these. Okay, then do the next question. Question number 3. No, silence, silence, stop talking. Do the next question, and if there's any doubts the online students have, you can ask in the chat. So use the knowledge that we got here because they have given a data FC is equal to 2B. So using that, you can write 2 more data. So if there's anything unclear in the stuff that we have done so far, you can ask. And even online students, send a message in the chat if there's anything unclear. So when you're finding AE, you have to start from A and go up to E. So when you are starting from A and going to E, you have to add the vectors that you find on the way. That's all. So you have to add all the vectors that you meet on the way when you are going from A to E. That's all. Okay, now look at the hands up who got AE in question number 3. Who has taken vector AE? Hold on. So it's a small thing when you are taking vector AE. Look at this. So you have to start from A and you have to go to E. No, kuda. You have to start from A and you have to go to E. So what is the path you can take? You can go from A to F, F to C, C to D, and D to E. All the vectors are known vectors. From you can start from A to F, F to C, C to D, and D to E. So then all the vectors are known vectors, and you can find AE. So take that path. A to F, F to C, C to D, and D to E. සයිලන් සයිලන් දැන් මම අර බැරි එක කියලා දුන්නාම දැන් ඔක්කොම තනියෙන් කරා වගේ කතාව. සදනන්ද තනියෙන් can complete all the 5 vectors. So because when you find AE, you can get all the other vectors. Okay. So we have A, B, C, D, E, and F. Silence, silence. So we have been given that DC is A. So when this is A, even this is A. And FC is 2B. So I told you when this is a regular hexagon, it should be regular. This side is half of this, so this is B. And even this is B. The first vector that they're asking is to find AE. So when you're supposed to find AE, I told you need to start from A and go to E. The small thing making a particular games thing, and you get this paper games where a piece of a cheese is kept in one corner and a mouse is kept in another corner. Help the mouse to find the cheese. And you do in this way. I've done those games. What you have to do, start from A and you have to go in, like you can take any path. You can take any of these paths. So what is the easiest path from A to E is AF and FE. But the thing is, this vector is unknown vector. We have to follow a path where all the vectors are known vectors. So then there's no use of going in this path. So what is the path I'm taking from A to F to here, and this one. And then you can write, okay, AE is equal to a minus A plus 2B minus A minus b. Minus a plus 2b minus a and minus b, which gives you b minus 2a. So this gives you b minus 2a. Second one, EF. Then you have to find EF. So when you have to find EF, since I have already taken EAE, start from E and come to F. So that is EA, not sports, plus AF. EA plus AF. What is EF? I know AE, the minus of this is EA, a minus B minus 2A plus AF. So what is AF? AF is even minus. So we get minus A plus 2A minus B. What is EF? It's A minus B, no? Okay. Hands up who got B minus 2A for AE and A minus B for EF. Then AD. Then AD. Now you know what is this? This is A minus B. EF is A minus B. So then I'll take AD. What is AD? I'm taking this path. AD is equal to minus a minus of this minus A minus B and plus B. Got it. So what is AD? Minus A minus. So look at the arrow. There should be arrows. Minus of this. Minus A minus B and plus B. So then AD minus A minus A plus B plus B. This is equal to 2B minus 2A. And there is another way that how you can take this, because I know this is A minus B, which means even this is A minus B. This is even A minus B. If you take the direction change, this is B minus A. This is B minus, if this is A minus B, this is A minus B. If you consider the direction change, it's B minus A. And AD is twice of this. That is the same answer, no? AD is twice of this. Or you can take the answer that AD. Even though you have completed, don't even talk with the one next to you. When it's a really disturbance. So then AD can be even written in this way. And then we have ED, the hardest one. So what is ED? It's B. ED is equal to B. And CA, this is CA. Question number 5, CA is equal to minus of this minus B minus A, and even the minus of this minus B. Minus B plus A minus B, I get CA is equal to A minus 2B. Okay, I get CA is equal to A minus 2B. A minus 2B. Clear, no? Minus B. Yeah. Okay, here's a book on these 5. B minus 2A, A minus B, 2B minus 2A, B and A minus 2B. Hands up, book up. Okay, so I'll give 1 minute. You can complete the work if you haven't taken the answer. Okay, okay, write the topic. The next topic, position vectors. Silence, silence. Array, silence. Try the topic. Silence. Position. Position vectors. Okay. Like, did I tell the story about like these rejections and all? Not rejections being the rejections that comes to your mind. Did I tell about building brands and getting rejected and then building their own brand? A short story, a small thing. Okay. I can remember na kiwa ke matai. Okay, so a small thing. Wait. Okay, so now one thing that silence on. So one thing which happens now day by day when we are talking about these generations and all, the level of comfort is increasing. How comfortable life is increasing day by day. For example, if you think about a human who lived in this 19th century, so we are in the 21st century, not the 20th, 19th century. He didn't have any vehicle to travel. So the mode of traveling was using animals or a similar way. Silence, silence. And if you think about a man who lived in early 20th century, there were no any air conditions invented by then. And there were no any planes. So day by day, with the development of the technology, the level, the standard of the life, the quality of the life, the comfort of the life all goes up with the advancement of the technology. So that we have to admit. But one negative impact of this is because of this quality and the comfort of the life goes up. Nowadays, people are really that I can say that it might be happen in a genetical way. The genes in nowadays humans, I'm not referring to people who are born after 2000. Now, everyone, this like nowadays humans, they don't have this capacity or the potential to give a to be let's say to be resilient or to give a good comeback when they get rejected. So that is a genetical error that we see in these days of humans. Like if you think about a human getting rejected in some kind of a thing in 50 years back, the way he faced that, the way he how resilient he is, the way he comes back is way different with a human in nowadays because of this all the things I have mentioned. But there are some interesting stories, like even nowadays stories, interesting stories, how brands were built because of the rejections. Okay. So one story I think I can't remember like whether I have mentioned it before is this Adidas and Puma. So even I don't know whether you know this. Adidas and Puma are two companies of two brothers. Their surnames were Dassler brothers. So initially they had this shoes Dassler brothers, and then because of a conflict between them, the elder brother took the company, and the elder brother made the name like made shoes with the name Adidas. And then the younger brother went in his own avenue, and he put up this Puma. So that's how Puma and Adidas came. So one interesting thing, there used to be a software developer in Facebook. So Facebook was sorry, not invented. Facebook was found in 2004, somewhere around 2004 or 3. So Facebook was there in 2004. And as you know, the founder of Facebook was Zuckerberg, Mark Zuckerberg, that you know. And then in 2009, there was a software developer, like before 2009 in Facebook. His name was Brian Acton. His name was Brian Acton. Then he was working in Facebook, and then I think he has applied another job inside Facebook, but he has got rejected, and then he had to come out of Facebook. So he is not anymore in Facebook. So that is the rejection that he got. But what did he do? He combined with another one called Jan Koum, and these two together developed another app in 2009. So because of this rejection that Brian Acton got from Facebook, he thought of developing his own app, and they developed that in 2009. And by 2010, 11, 12, it became one of the most used apps in the world. And what is the app that they developed? It's WhatsApp. And how popular the app became, later in 2014, Facebook saw WhatsApp as a threat. So what did Facebook do? They bought WhatsApp from these two to an amount of $19 billion. Not million, $billion. So if you don't have understanding about what is $1 billion, the entire Cinnamon Life restaurant, the hotel, that is the highest investment done by a private sector in Sri Lanka, that is $1 billion. So it's like 19 Cinnamon Life hotels and including the two towers, the apartments. And if you're still not aware about, no, still you're not sure whether it is big or small, the loan, the debt that IMF gave to Sri Lanka when we were having an economic crisis to save Sri Lanka was $3.4 billion. And they didn't give that directly. They gave that as installments of 400 million, and still we are getting installments of the loan. So that is $3.2 billion. And that is even before the economic crisis. But then they bought this for $19 billion. So why did, like, I don't say that if they were not, if Brian Acton was not rejected by Facebook, there won't be app called WhatsApp. Someone will make a similar app, or maybe Brian Acton, he might make the same app while being inside Facebook. And then only Instagram came in 2014, 15, and that's how they combine this Meta group. Now Facebook is under Meta company. They have Facebook, Instagram, WhatsApp, and Threads. No, they have Threads. Like they have similar to Twitter, they have Threads. So that is one major rejection. And then another one. There used to be a Japanese mechanic, and his name is I'll just write it. I'm not sure about the pronounce, how to pronounce it. Something like this. Let's say, because the CH, sometimes we pronounce it as K. The Richt is RICHT. So I'm not sure whether this is Sokioro, Sochioro, anything related to, like, let's say S. His name is S. He's a Japanese mechanic. And what did he do? He made piston rings. So piston is a part in the engine. And he had a company, they made piston rings. And they were supplying even piston rings to Toyota. And later they made a new piston ring design, and they pitched that design to Toyota, but they got rejected. And it is said that this Ochioro, the person, he has applied for a mechanical engineering job in Toyota, but he got rejected. He got rejected. So he was initially making piston rings. Their company was initially making piston rings, and he even applied a job for Toyota, and then he got rejected. So then he had this knowledge about automobiles. Then after this rejection, so there were two rejections: the new piston ring design, and even the job that he applied in Toyota. He was rejected. Then later he thought of putting his own company. So what is his name? Is Sochiora Honda. So that's how the automobile company Honda came to the world. So most of these brands that we talk today comes with a rejection. There is a backstory of a rejection. And there is this, I don't know whether you have heard about these cars. There is a car company called, still there, I think in Italy. It's Alfa Romeo. They make some good cars. Hands up who know about this Alfa Romeo. Okay. So then there used to be, okay. So then there used to be a, okay, silence. Okay, listen. ඔගොල්ලෝ කියනද කතා? So there used to be a employee in here. His name was Enzo. And like I haven't seen these instant like I haven't seen these incidents with as eyewitness. No. So I can say that to make this more creative, I can say that Enzo was kicked out of Alfa Romeo company. And then if you even Google them, you will be having similar stories with few contradictions. But Enzo, silence. So Enzo used to work in Alfa Romeo, and they say that because of an internal conflict that he has come out from the company, but some say that he have officially resigned. So somehow he was in Alfa Romeo and he came out of the company. And then he's from even Italy. The company was in Italy. Then he started his own automobile company because he had the knowledge. He gained the good knowledge from Alfa Romeo. And then he started making his own cars. And his name is Enzo Ferrari. And that's how this Ferrari cars came to the world. And when Enzo Ferrari became a popular character in Italy, so he was a superstar in Italy because Ferrari cars those days are sports cars, luxury cars, and with all these F1 Formula One races, Ferrari was dominating for a good time. So like he was a superstar in Italy. අපි ලංකාවේ ධම්මික පෙරේරා වගේ ටිකක් he's not a superstar, but let's say like he came in this way. Okay, so then there used to be a wait. Now when you are listening a story, to enjoy the story, listen it properly. Meanwhile, the story don't give comments and only you know a part of a story. Don't tell your story. Then there's no use of I'm telling the story. No. So in this, there used to be a tractor company in Italy owned by Ferruccio. So he was a good Italian businessman, but what he was doing is he was making tractors in a large scale. He was having the largest tractor company in Italy. Yeah, largest tractor company. And in this period, these Ferrari cars were having a small issue in their clutch. In their clutch, they were having a small issue. There's a clutch too in vehicles, there are clutch. See, if there are three pedals, three CBA manual cars, we have the clutch, brake, and the accelerate. If it is auto car, you don't have a clutch. That doesn't mean that there is no any clutch. The clutch mechanism is done in auto way. When you put the gear, the clutch mechanism automatically happens. So that's why you don't have a clutch pedal. Auto cars වල clutch එක නැහැ නෙමෙයි. Clutch එක නැත්තම් වාහනේ දුවන්න බෑ. There is a clutch, but there is no separate clutch pedal. And if you have four pedals, like you have three pedals, one separate and one is the corner one, and you are telling me, sir, our car is an auto car, but still there are three pedals. The third pedal is not the clutch, it's the handbrake. Okay, because nowadays cars, there are no any handbrake in this way. They are having this, so you can name it as the leg brake. So like that's why when your father stops the car, they just press this. So we still name this handbrake, but it's not the handbrake. Handbrake, මෙහෙම අදින්න තිබ්බහම. So like even though we term this the handbrake, දැකලා දිනා තාත්තා පල්ලෙහාට ගිහලා මෙහෙම දානවා. නෑ. So now it should be the leg brake. So here, okay, silence. So there used to be a small mechanism error in the clutch of the Ferrari cars. So what did Ferruccio do once when he met this Enzo Ferrari, the owner of Ferrari? This tractor manufacturing company owner was telling to Enzo, your cars, even he was having a Ferrari car. Even this Ferruccio was having a Ferrari car. He's not a farmer. He's the owner of the largest tractor company in Sri Lanka. For example, like not in Sri Lanka, in Italy. So, for example, if you like, you can't think that he's a game in Govia wage. He's a farmer, not in that way. He's even a good businessman. So what he has Mary. Okay. So what he has proposed to Enzo, he have told that your cars are having a issue with your clutch. So I have developed a mechanism, so I can introduce it to you. So if you want, you can use the mechanism. So most of the clutch errors that Ferrari cars are having will be solved. So who is Enzo? One of the best ever automobile manufacturers in Italy. Not one of the best, by then the best ever. Who is Ferruccio? The largest tractor company owner. So do you think that Enzo will accept something from Feroz? They have the status and say, who are you? What is your business? You are making tractors, I make cars. So what has Enzo told to Ferruccio? He has told, you make your own tractors, I'll make my cars. So that's what Enzo has told to Ferruccio. That is mentioned even in Ferruccio's autobiography, that Enzo has told him, you make your tractors, I'll make my cars. So later, what did Ferruccio know? He has the company, he has the technology of building like automobiles, and he have this new pitching idea where Ferrari cars went wrong. So he thought of making his own cars, and his name is Ferruccio Lamborghini. And that's how, I'm not sure about the spellings, that's how Lamborghini cars came to this. The world. So these are real, like even though they are interconnected, real stories. And in Lamborghini, there was a worker. His name was Horacio. You can search these names. If not, I can lie. Okay. Silence, silence, man. So even when I'm telling a story in the single medium class, that's the one reason that I don't like to tell any story in your class. Even the single medium class, when I say something, next moment, okay, they are ready to listen the story. So that's why really I don't like to like share some stories with you. Because when I start like telling a story, different stories. And when we get a point like something that is a bit with a humor, and you laugh and you keep laughing and keep talking. So that's why. Because out of like, if I say 5 stories in the single medium class, in the English medium class, I only stay like one. Not every week I'm telling a story. But once in every 3 weeks, I just share a story with them. But in the English medium class, it's like 1 in 3 months. ඒකත් කියන්න අද පොඩ්ඩක් කල් ගියා. එහෙම අමාරුයි because you are not like disciplined students no, comparing to the single medium class. Your discipline is really low. I have told that before. කියද්දිත් කතා කරනවා. Okay, so there used to be a employee called Horacio. So he has brought an idea where to build carbon fiber cars. So carbon fiber is a material high in strength but really low in weight. You must have seen there are carbon fiber bicycles where the bicycle body, like I have seen that they are lifting with one finger. The bicycle, not the motorbike, the bicycle body without wheels that you can lift it with a finger. Some of the bicycle frames, you call it as a bicycle frame, is even less than 800 grams. Because when it is made by carbon fiber, rock solid, good in strength, but the weight is really less. So he has brought the idea to Ferruccio, by then the car designers to Lamborghini. We can use carbon fiber to build cars. It will increase the speed of the car and the strength of the car. Because when it is less weight, the speed increases. Later, they have rejected that idea. So again, same thing as a sequence of the story. He has come out from Lamborghini and he has put his own company. And this name is not that much famous like these two, but cars are famous. His name is Horacio Pagani. So if you know about Pagani cars, I don't know whether you know about it. That's how Pagani cars came. And one last story is before these 1980s and 1970s, even now, the main one of the main computer manufacturers were HP computers. So HP stands for Hewlett Packard, not any other meaning. Okay. So HP stands for not head prefect, and the meaning that comes to your mind, it's not HP, it's HTTP. So not that this HP is a computer. I know that many students who are using HP laptops doesn't know what does this 2 letters stand for. It's Hewlett Packard. Okay, hands up who have HP computers. Okay. So then there were two entrepreneurs have pitched the idea about their personal computer to this HP management. So later that idea got rejected and they came up with their own computer brand. So who were these two? One was Steve Jobs and the other one is Steve Wozniak. So when you say Steve Jobs, you know what is the computer brand that he brought? It's Apple. He is the founder of Apple. I don't know whether you know him, but he is the founder of Apple. So most of the technological giants, automobile giants, and even software giants has come up after the rejection. So they got rejected by HP. Because of that reason, they came up with their own computer brand, which was Apple. Enzo was not rejected. I'm not sure about that. But from Alfa Romeo, Ferrari came because of the not a rejection because of what Ferruccio was said by Enzo. You make your own tractors. He didn't limit to tractors. He made his own cars. And Lamborghini came because of the carbon fiber thing. Pagani came. Pagani cars came. And even here, because Brian Acton was rejected from Facebook in 2000 and early 2007-8, he made up his own app, and then he sold the own app to the Facebook for $19 billion. Just imagine getting rejected by Facebook and building an app, becoming one of the most popular apps by then, and selling it to Facebook. Selling it when if he sold it to Google, it's something a different story. He sold it again to Facebook. And then not for a small deal, $19 billion. So this is how normally rejection stories come. Nice stories, but nowadays, from when we are moving forward, I don't think, let's say that we are in a period in 2100. If I'll be alive, I'll be more than 100 years. 2100, then we won't be hearing these type of stories, because as I mentioned, because of this increase of the standard of life, quality of life, the genes or the resilient power, the giving a good comeback has gone down. But still we have nice stories. Okay. Okay. So here we have the topic position vectors. So I'll take just 5 minutes to explain this. Then we are in the same place where we stop the single medium class. Okay. So what is a position? Now listen properly. Sit properly and listen this. Can't talk. I can't see anyone talking. Okay. Stay in the same way. So what is a position vector? Now let's say here we have this point A and here we have B. And the position of point B with respect, if I'm taking this vector in this direction, it gives me an idea about the position of vector B with respect to A. Let's say that this vector is having a magnitude of 20 kilometers. So then I know B is located to the east of A at a distance of 20 kilometers, which means this vector gives us an idea about the position of B with respect to A. With respect to A. So for example, let's say now we have Nugegoda here and we have, let's say, Colombo 7 here. And here we have Maharagama. So let's assume that the distance from Nugegoda to Colombo 7 is even 6 kilometers. Let's assume the distance from Maharagama to Nugegoda is even 6 kilometers. So if I say the distance from Nugegoda to Colombo 7 is even 6 kilometers, the distance from Nugegoda to Maharagama is even 6 kilometers, you get the idea or the feeling that Colombo 7 and Maharagama are located on the same point. No. If I say that Colombo 7 is 6 kilometers from Nugegoda, and even Maharagama is located 6 kilometers from Nugegoda, you might get a feeling, okay, both the cities are 6 kilometers away from Nugegoda, which means you get the feeling they can be on the same point. So Colombo 7 is equal to Maharagama. You might get a feeling in that way because both are 6 kilometers away. No, but if I say Colombo 7 is 6 kilometers to this direction from Nugegoda and Maharagama is 6 kilometers to this direction, then you have a clear understanding about the position of Colombo 7 and Maharagama with respect to Nugegoda. So this vector which gives the position of another point, the vector that gives the position of another point with respect to one point is known as the position vector. Is known as the position vector. So here we have this position vector AB that gives us the idea about the position of A with respect to, sorry, position of B with respect to A. So what is AB? Position vector of B, position vector of B with respect to A. So the position vector is given with respect to A. So if I take another vector, here we got C and here we got B. You now tell me what can you say about vector CB? What can you say about vector CB? Tell me. That is the, what is CB? Position vector of, tell me, I'm not going to let you go if you don't say properly. What is CB? Position vector of B with respect to C. So when it is CB, position vector of B with respect to C. So a position vector gives us an idea about the position of a point with respect to another point. Okay, right in this way, a position vector, a position vector gives, a position vector gives the location of a point, gives the location of a point, location of a point with respect to another point, with respect to another point. Okay, then write these two examples. AB is the position vector of B with respect to A, which means the location of B is given, the location of B is given with respect to A. The location of B is given with respect to A. So next one is CB. So when it is CB, the position of, position vector of B, it has been given with respect to C. Okay, and there might be instances where you have been just given a position vector without mentioning with respect to which point. For example, like they have just given position vector of, position vector of A. So they haven't mentioned with respect to which point. And even position vector of B. So if a position vector has been given without mentioning with respect to which point, then we are referring to the origin or the point O. So if a position vector has been given, position vector has been given without referring with respect to any point, that means we have been referring to the origin. So the position vector of A means the position vector of A with respect to the origin O. So that is the OA vector. And even here, the position vector of B, that is OB, because if they haven't given with respect to which point, we are referring to the origin. Clear? So here it's with respect to O, with respect to O. Okay, write in this way, put a red star mark and write in a normal pen. Write in this way. If a position vector has been given, if a position vector has been given without mentioning without mentioning with respect to which point, without mentioning with respect to which point, it should be considered, it should be considered with respect to the origin. It should be considered with respect to the origin, comma O, sorry, within brackets O, with respect to the origin, within brackets O. Then write these two position vector of A means OA. Position vector of B means OB. Position vector of B means OB. Okay. Then just write this and keep. Let's start from here next week. Write this in a black pen, write note, and in a red pen, in a black pen, write note, and then in a red pen, write this addition of position vectors. Addition of position vectors. Okay, you can get ready to go. Okay. 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 So okay. I'll talk to the newcomers after the end of the class. So the newcomers who have joined the online class, just remain after the class. You don't have to leave. Just remain after the class, and I'll tell them what to do. So we started vectors, and next week, like you're having vacation from Friday onwards, I'll be doing 2 extra classes in the first 2 Tuesdays of the vacation, which means next Tuesday and week after Tuesday. So next Tuesday is the 11th and 18th. I'll put a proper post. So next week we'll be doing coordinate geometry 8 to 2 o'clock. And then we are having the normal class from 3 to 7 that we have. And listen. So 3 to 7 we are having the normal class, and I'll be putting 2 extra classes. One is the 11th of Tuesday, and the other one is 8. Stop talking, huh? Other one is 18th of Tuesday. So next week I'll put a post in the group. Come by 8 o'clock. We'll be starting coordinate geometry. Coordinate geometry, and week after logarithms. That's all. And then I won't be putting any other extra classes for the 2027 English medium class. Okay. And next week I'll let you know properly whether we can do it in week after without going 11th and 18th, or even I can do 11th and 25th. So let's discuss that next week. So anyways, next week, come by 8 o'clock, we'll be doing coordinate geometry. So bring your vectors book, and you don't have to bring another new book. You can bring the same book. What is the last lesson? We did trigonometry. You can write it in trigonometry. Coordinate geometry. So bring a BO book and bring your vectors book. Okay, we are done for today. You can go home safe. Okay, so a small thing, the ones who joined online as new students, what you have to do, send this number WhatsApp message. Okay, send this number WhatsApp message and get the 2027 English medium Telegram group link. Okay, so get this link and then join to this group, and all the lessons. So last month we did this lesson modulus graphs, except this lesson, every other lesson has been uploaded to YouTube. So I have uploaded them in YouTube, so then you can easily access them. What you have to do is, let's say that you want to follow one of the previous lessons, even modulus graphs will be even uploaded to YouTube by this week. But except this one, every other lesson is in the group. So what you have to do if you want to go through, like we have done polynomials, trigonometry, inequalities, partial fractions, few other lessons. If you want to go through those lessons, what you have to do, send him a WhatsApp message and get the PDF. Okay, get the PDF later after you register properly. You will be getting the initial tunes even. For now, just send him a message and get the PDFs, and then you can start watching the recordings. Okay, so I only expect what I want in this week to first get familiar with my teaching way, the way that I teach and all these. And by next week, I'll tell you what are the lessons that I want you to cover soon as possible. Because we'll be starting the second part of trigonometry in December. Before that, I want you to cover the first part of trigonometry at the end of November. So that is the only requirement I have. In every other lesson, you can freely watch them and cover those lessons. But the initial one, the main one is trigonometry, because we'll be starting the second part of trigonometry in December. Until then, before that, this vacation period, you can go through the trigonometry recordings. Clear? Okay, so send him a WhatsApp message, get joined to the group, and you have to register. Today you might be directly you got the link from the group, no? So register in this account, website, make an account as a 2027 English medium online student. And make sure that you put the addresses properly, because you will be getting tunes. All the tunes will be couriered to the address that you have given, you have entered. So make an account in this website as a 2027 EM online students, because there are some feature differences for online students who have joined to the website and physical students who have joined to the website. So there are some differences in the features. So make sure that you are joining, registering as a student 2027 EM English. Okay. Okay. So if there are any details that you want to get, you can send a WhatsApp message to this number and get them clarified. Okay. So we are done for today. Can stay safe at home.